Hello students, welcome back to our EduStar YouTube channel. If you are visiting our channel for the first time, make sure to subscribe to the channel and share it with your friends. You can also join our WhatsApp group. The link is in the description and the comment section. Alright, let's get started into the video. In this video, I will be covering the topic Univariate Data Analysis. Univariate data analysis consists of the following analysis techniques: data visualization, central data, dispersion, shape, special univariate plots. Central tendency. It is practically difficult to remember the data. Central tendency can explain the characteristics of the data. Central tendency can explain the characteristics of the data, and that further helps in the comparison with the other data. There are the following central tendency measures: mean, median, and the mode. Mean has other three types: arithmetic mean, geometric mean, and the weighted mean. Mean. Mean represents the center of the data. We have three different types of mean: arithmetic mean, weighted mean, and geographic mean. Let us see what is arithmetic mean. This is the commonest measure used in our daily conversation. For example, average income of a person, average marks of a student, etc. It can be calculated by using the formula x bar equal to x1 plus x2 so on up to x1 divided by n. It can be also written like this: 1 by n summation of I equal to 1 to n xi. Let's see one simple example on this. X equal to 10, 20, 30, 25, 5, 7 and 9. Here n equal to 7. Using the formula 1 divided by n summation of I equal to 1 to 7 xi, and add all these elements, divide by 7. It will be equal to 15.17. Weighted mean. In the case of arithmetic mean, all the elements will be given equal priority, but in the weighted mean, different importance will be given to different data points. The following formula is used to calculate the weighted mean: x bar equal to wi x1, w2 x2 and so on up to wn xn divided by total number of weights w1, w2, w3 and so on up to wn. It can be also written like this: summation of I equal to 1 to n wi xi divided by summation of I equal to 1 to n wi. Let's see the one example. Calculate the weighted mean for the following item. Here x represents the item and w represents the weight. So we need to calculate the weighted mean for this. 5 into 8 plus 10 into 4 plus 25 into 5 plus 20 into 10 plus 25 into 7 30 into 6 divided by weights 8 plus 4 plus 5 plus 10 plus 7. Here this will be equal to 760 divided by 40, and the answer will be 90. Next, here comes the geometric mean. This is the formula used to calculate the geometric mean: pi from I equal to 1 to n xi the whole power of 1 by n. It can be also written like this: nth root of x1 into x2 so on up to x1, where n is the number of items and x are the values. Let's see the one basic example to find the geometric mean. Here n equal to 4. Geometric mean equal to 10 into 25 into 5 into 13 the whole power of 1, n value is 4, which is equal to 13.915. Next topic is median. What is median? The median is the middle value in the distribution. In the case of odd distribution, the exactly middle value is called the median of the data set. Let's see the example. Here there are 5 elements. So middle element 55 is the median. But in this case there are 6 elements. So you need to add the middle 2 elements and divide it by 2. Instead of doing this, first you need to write all the elements in the ascending order: 10, 25, 27, 30, 50 and then 55. Then take the middle 2 elements, add those 2 elements and divide by 2. You will get the median as 28.5. Calculation of median in the case of continuous series. What is continuous series? In the continuous series, the class value of average variable is grouped into several class intervals, such as 0 to 5 is class 1, 5 to 10 class 2, 10 to 15 is class 3, along with the corresponding frequencies. Example of continuous series is shown in the table. Marks and the number of students: 50 to 60. These marks are scored by 10 students. Between 60 to 70 there are 8 students. 70 to 80 there are 12 students, and 80 to 90 there are only 5 students. Step 1. Arrange the data in either ascending order or the descending order. Step 2. Determine the cumulative frequency, either CF, by adding the frequency with the previous frequency. Step 3. Find the total frequency, that is sum of all the frequency. Step 4. Determine the median class, that is n by 2. Step 5. Apply the below median formula to calculate the median. So median equal to L plus n by 2 minus CF divided by F into H, where L is the lower boundary of the median class, n is the total frequency, n by 2 is the median, CF is the cumulative frequency of the class before the median class, F frequency, and H is the class width. To calculate the median, start by taking the class interval, number of frequency, cumulative frequency. Class interval 50 to 60, 10 students scored. 60 to 70, there are only 8 students. 70 to 80, 12 students, and 80 to 90, 5 students. Cumulative frequency, initially take the value as 10, add 10 with 8, 18, 18 plus 12, 30, 30 plus 5, 35. To calculate the number of frequency, add all these, you will get 35. So total frequency equal to 35, which is also denoted as n. Calculate n by 2 by dividing 35 by 2. You will get 17.5. Now 17.5 lies between the cumulative frequency 10 and 8. So we have to choose the median class for the cumulative frequency 18. As 18 is more than the 7.5, so the corresponding median class is between 60 to 70. So now the lower boundary of the median class is 60. N, the total number of frequencies are 35. Cumulative frequency of the class cumulative frequency of the class before the median class is before the median class is 10. Then here frequency is 8 and h equal to class width 10. By using this formula, median equal to L plus n by 2 minus Cf by f into h. Substitute all the values here. 60 plus 17.5 minus 10 divided by 8 into h. You will get a value as 69.375 is our median. Then the last topic is mode. Mode is the value that occurs more frequently in the dataset. The value that has the highest frequency is also called mode. Mode is only for the discrete data and not applicable for continuous data. To calculate the mode, first we should find the frequency of each the data, and the highest data which has the highest frequency is the mode of the data set. For example, here are the data and these are the frequencies. Here 200 is the mode of the data set as the frequency is 150, which is the highest. Thank you, students. Let's see you in the next video.